Hey guys, today we're going to do 5, 6, down to 2 lessons. All right, we got 5, 6, 5, 7, both on inverse trig. Today we're going to do derivatives, tomorrow we do integrals, and then we call it a day. All right, so inverse trig, all right, a lot of the stuff you see here, you guys did in pre-cal. All right, when you see arc sine, all right, arc sine is really the same thing as the inverse of sine. Okay, so like you see how it says arc sine of this, then it says cosine -1. Well, that's the same thing as arc cosine. All right, good news is we're not going to do any of this because you guys already did some pre-cal. We're not going to waste our time doing it again. The part we care about in calculus, we are going to do the derivatives of inverse trig. All right, so now notice it says here arc sine. Well, that arc sine is the same thing as sine the negative first. Arctan is the same thing if it has tangent to the negative first. This would be secant to negative first, cosine negative first, cotangent negative first. Just means the inverse. So whether it has arc cosine or cosine negative first, these are the formulas we're going to follow for the derivative. All right, now, where do you think I can find all of these equations? Well, that's on our formula sheet. All right, so if you look at the formula sheet, which we have here, so these are all the derivatives of just a regular trig. Here you go. This is all of the inverse trig. Notice on the formula sheet, it has it to negative first. It doesn't say arc sine, arc cosine, but just realize they mean the same thing. All right, and you see all of the formulas are the same ones that you see right here. Okay, so today we are just going to do these examples right here of inverse trig, derivatives inverse trig. And then tomorrow we will do the integrals, which are going to be these three guys over here. And then we will be done with calculus for this year. All right, so to do this first example, all right, arctan of the square root of x, all right, that is the same thing as tangent to the negative first. Here on these formulas, it says arc all of them. And here it just has it to the negative first. All right, so let's go to here. All right, so this is basically, we're just going to be following like a recipe. It's all it's going to be. So arctan square root of x, or tangent negative first of square root of x. So we are obviously looking right here. Okay, so we are going to follow the formula sheet. So du, well, what's u? U is whatever is coming after the arctan or the tangent negative first, the square root of x. So we need to take the derivative of the square root of x. All right, the square root of x is x to the 1/2. All right, bring it out front, it's 1/2 x to the negative 1/2, which means it's 1 over 2 root x. Hopefully you have that memorized by now, but in case you don't. All right, 1 over 2 root x. That's your du, over 1 plus u squared. Well, what was my u? U is the square root of x. What's the square root of x squared? X. All right. Now, the only thing that's wrong with this is okay, except for the fact we have a complex fraction. All right. We do not want a complex fraction. So what we do when you have this 1 over, this is just going to go in the bottom. This is the same thing as 1 over 2 root x times 1 plus x. And there's your answer. If you left it as just this, probably would get like a ½ point off on an assessment. This is the correct answer. All right. So move to the next one. Inverse sine. So now we're using this formula. In this problem, whatever comes after, this is the u. All right. So I do du. What's the derivative of 3x squared? Well, it's just 9x over the square root of 1 minus u squared. What's the u? 3x squared. What's 3x squared? That whole quantity squared? That's 9x to the 4th. Done. There's your answer. 9x over the square root of 1 minus 9x to the 4th. All right, we're just following exactly what it says. All right, arcsecant of e to the 2x. So in this problem, e to the 2x is my u. Arcsecant, where's that? It's right here. So just follow the directions. du. What's the derivative of e to the 2x? Okay, well, how do I get e to the u? If you forget, you go to your formula sheet, use the derivative of this. E to the u is e to the u du, right? So it's e to the 2x, you rewrite it, times du, which is 2x, the derivative of that is 2. So it's e to the 2x times 2, or 2e to the 2x. You can keep it like this, I don't care. Over, which are we doing here? Arcsecant. So it's just the square, absolute value of u. Well, what was u? E to the 2x square root of u squared. Well, what's e to the 2x squared? Well, power to a power, it's just e to the 4x minus 1. All right, so it looks, and the final answer is like, are you kidding me? Now, obviously, we can put the 2 here like that. Now, all right, what I just noticed here, and if you left it like this, I'm probably not going to take off, to be honest with you. But you can notice is that these e to 2x's could cancel, actually just leaving us with 2 over the square root of e to the 4x minus 1. That's what you should write as your final answer. All right. So we're just following, this is like a recipe book. You're just following the recipe. And if you don't, you might be that to find the derivative of u, you might have to look at your formula sheet that tells you how to find the derivative of that and just follow the recipe of that. Just follow the formula. All right. All right, this one here. Arc cosine of 3x plus 5. So 3x plus 5 is going to be u. We're going to use this formula here. All right, notice the cosine, the cotangent, cosecant, what do they have? They're all negative, just like we did with other derivatives. All right, just because the inverse doesn't change any of that. All right, so negative du. So it's going to be the derivative of 3x plus 5 is just 3. So it'll be negative 3 over the square root of 1 minus, well, what's 3u squared, which 3x plus 5 squared, and you do not have to FOIL it out. Just write 3x plus 5 squared. And there you go. There's your answer. All right. All right, next one. Natural log of 5x is going to be our u. Arc cotangent. Where's arc cotangent? That's right here. So it's negative du. Well, how do I figure out the derivative of the natural log? If you forget, you go to your formula sheet. It's right here. The derivative of natural log is du over u. All right. So the derivative of 5x is 5 over 5x. Whoops. Yep. Over 5x. But if you remember what happens, that's just 1 over x. So it's 1 over x over. So the derivative of natural log of 5x is 1 over x. All right. Over 1 plus u squared. So the natural log of 5x, we just need to square that. And that is just going to be the natural log of 5x. We're just going to put a square. That's it. Now, the only thing that we can do here is I don't want a complex fraction. So we just take the x and move it to the bottom. So my final answer will be 1 over, this x just goes to the bottom, times 1, whoops, not, I wrote a t there, or plus sign. 1 plus the natural log of 5x squared. So there you go. All right, there's your final answer. Like I said, if you leave it like this, okay. It's not perfect, but pretty much acceptable. Okay. All right. Number, or letter F, I should say, arc cosecant. So one type of example we have not done yet. All right. 4 to the x plus 3 is going to be my u. All right. So I got to take the derivative of 4 to the x plus 3. Well, how do I take the derivative of 4 to the x plus 3? Well, go to your formula sheet. Which one of these fits? Oh, wait, we have a constant being raised to a variable. It's this formula right here. That's a to the u, natural log of a, du. That's what we just did in our last section, 5. All right, so it's a to the u, so we're going to rewrite what we just had, times the natural log of a, which in this case is 4, times the derivative of u, right? So du, which is x plus 3 in this case, which is just 1. All right, so we have negative 4 to the x plus 3 times the natural log of 4. I don't need to put the 1 there. All right, over the absolute value of u, which is 4 to the x plus 3, square root of u squared, all right, which is going to be, just going to write 4 to the x plus 3, and we're just going to square that, all right, and then minus 1. These just cancel. All right. I just was talking for a while, but I realized it was not playing. So I just went and finished this out. I think I had already all this done, right? And it's those cancels, not negative natural log of 4. If you want to write it like this, you can, or you can actually do power to power, gives you 2x plus 6. Either way is fine. All right. Now the last 3 here, because we did an example of each of the inverse trig, have the inverse trig in it. They're just not the main thing. They're within other things. So, for example, this one is 2 raised to the inverse trig. Well, this is an a to the u type of problem, right? That is this right here. This is a to the u natural log of a of du. All right, so a to the u is 2 to the sine, it means you just rewrite it, negative 1 of 4x times the natural log of a. We're just following a recipe. So it's natural log of a, which in this case is 2, times the derivative of u. Well, what is u? U in this case is this. So that means I now am going to go and use the formula for inverse sine, which is, look here, I can now use this. So to get this du, I'm using this formula, all right? Which is du, use my 4x, the derivative of that is 4, over, all right, over the square root of 1 minus u squared. Square root of 1 minus u is 4x, that squared is 16x squared. All right, so my answer, and if you left it like this is going to be completely fine. All right, you can do is just put all of this on top, all over 1 minus 16 squared. All right. All right, next one. Natural log. How do we get the derivative of a natural log? Well, the derivative of natural log, remember, is du over u. Okay, so this is my u. What's the derivative of arc tangent 2x? Well, to get that derivative, right, to get this derivative, I then have to use arctan, which is this one, which is du over 1 plus u squared. All right, so it is du, which is derivative of 2x is 2, over, was it 1 plus u squared? See, I have to look back at it too. Yep, 1 plus u squared, which is 4x squared. All right, so this right here is my du over my u, which is everything there. So derivative of the inside over the inside. So I don't want to write arctan. I'm going to write it as all right, so this was a natural log. So this was du. To figure out the derivative of the inside, you had to use the inverse trig formula over the inside. Okay, and like I said, complex fraction, no good. Just move this to the bottom. So your answer is going to be 2 over 1 plus 4x squared times inverse tan of 2x. That would be the correct answer. But if you just put this, that would also be okay. All right. Now, last one here, just to show you, this is a product rule. All right. So you can do product rule. Remember, the product rule is the first, which is 3x squared, times the derivative of the second. Well, arc cosine, all right, the formula for our cosine is negative d over 1 minus u squared, square root of that. So negative, the square root of x is 1 over, the derivative of that is 1 over 2 root x over, what was it again? 1 minus u squared, right? So over the square root of 1 minus that squared is x, plus the second, which is cosine negative 1 square root of x, times the derivative of the first, which is 9x. All right. Like I said, you can leave like that, but probably what you should do is write it as 3x squared. All right. This goes on the bottom, so it's 2 root x times the square root of 1 minus x, and then plus 9x cosine negative 1 square root of x. All right. So these last three were just showing how we've done these types of derivatives before. They just now, to get certain derivatives, you had to use these formulas. Okay. So I'll give you a worksheet with some practice on these, post the answer key later in the week. But then we are now down to one more section, which we will just do the integrals of these, and then spend the rest of the time practicing and take one last assessment next Friday. All right, hope all is well. If you have any questions, please let me know. Take care.